All right, welcome back to Sunnyside Speed Shop. In this episode, we can get this rear end welded into this car. All right, so I bought this frame from Boling Brothers down in Lindsay, California. And to save a little bit of money, I opted to go with my own rear end. I already had a Maverick rear end, which is a perfect width for one of these old Model A's. Um, Ended up saving close to like $2,000 by going with this setup because I already had it. But I have to weld the ladder bar brackets and leaf spring brackets on this rear end myself instead of having them do it. Derek down at Boling Brothers is awesome. I emailed him. I said, hey, can you give me kind of a ballpark of, where I should be set up? And he gave me all the information. He said, set your ladder bar brackets exactly, centered and exactly 26 inches apart. Set your leaf spring brackets at exactly 44 inches apart. So I'm set. But I still got to set my pinion angle. And he said, set your rear end, um, set your ride height at 3 inches off the frame, which I did. Cut some pieces of 2x4 here and set them at exactly 3 inches. Zip tied the rear end up to the frame, both sides. So that's exactly 3 inches. He said to set the pinion angle at exactly 3 degrees up, and then my drivetrain will be 3 degrees down. So we'll talk a little bit about pinion angle. So when setting your pinion angle, you want them to be opposite of each other. Well, what I mean by that is, in this one, the engine is going to be, and transmission is going to be 3 degrees down. The rear end is going to be 3 degrees up. So with the engine 3 degrees down, and the rear end 3 degrees up, they're perfectly parallel. So I won't have any harmonics, any weird vibrations, because one's going to be down 3 degrees, one's going to be up 3 degrees, and that's going to be perfectly parallel. That's the best I can describe it, at least. So the drive shaft will be at a perfectly parallel angle. And so it doesn't have to be 3 degrees. It can be 6 degrees and 6 degrees, whatever, as long as they're within a certain range of each other. I think I'd have to look it up, but I think if you can be off by a degree or maybe even half a degree, and still be all right without having any vibrations and stuff like that. I've dealt with it on like lowered leaf spring pickup trucks in the past, where you slam the back end of your truck 5-6 inches, and now you got a weird vibration. And they sell wedge lowering blocks to correct that pinion angle. So we're starting from scratch here. So I'm gonna set this guy at 3 degrees up, engine transmission 3 degrees down, and then if my ride height changes in the future, I can actually adjust these ladder bars to change the angle of the rear end. But I've got these things completely zeroed out right now, so I'm setting at 3 degrees, 3-inch ride height, and then in the future, if anything changes, I can just turn those adjustments on the ladder bars out, either on the top or the bottom, to crank the rear end any way that I want. So, all right, I already measured this about 500 times, but I'm going to show you guys exactly what I did here. I set this level on the flange. Doesn't matter that's the level, I just need a nice straight edge. And I took my measurement from the frame over, and I got exactly 8¼ inches. Go to the other side, make sure this thing's flat against that flange, not leaning any direction. Same thing. Exactly 8¼ inches. Boom, 8¼ inches. So I know that the rear end is centered from side to side, but it's also good to check to make sure your pinion's centered, because every rear end is not perfectly symmetrical where it's exactly, 24 inches of tube on either side. So you also want to take a measurement off the center. So right now, from that frame rail to center, I'm at 15 inches. And this way I'm actually 14 and 7/8. Well, I'm a 16th inch off. So my tubes are perfectly centered in the frame, and this is a 16th of an inch off, which is fine. 16th of an inch ain't gonna make no difference at all. When we get into 1/8 inch or 1/4 inch, maybe. I got a digital angle finder here. This is a Harbor Freight one. First thing I'm gonna do is set this thing on the actual frame itself. And I'm not perfectly level. It's coming out at 0.3. Now I'm gonna set this on my rear end. And now I'm at 3.3. So I know I'm exactly 3 degrees up. And I'm also gonna double check it on the yoke itself. 3.3, 3.3. So we know that's good. Turn that off. In addition to that, I want to make sure that these ladder bar brackets are centered. So I'm going to take a measurement off of here to the outside flange, and I'm at 12 and 5/8. Boom, 12 and 5/8. Now I busted my level. And we got 12 and 5/8. All right, so we got the pinion angle right. Ladder bars are centered. What I do really like so far about TIG welding is that you can do just like a fusion tack. You're not adding any material, you're just melting the existing material together, which is kind of cool. Can't do that with a MIG welder. Okay, that's tacked in place. Let me double check my measurements now. 12 and 5/8. 12 and 5/8. Cool. Okay, that's set. Double check. 3.5. 3.3. 3.3. Derek at Boling Brothers said to set these at exactly 44 inches apart. And that measurement was from outside to outside. So let me get the total width on this rear end. The rear end is exactly 51.5. Okay. So if I'm doing this correctly, I'll do 51.5, take away 44 inches. That's 7.5 inches left over. Divide that by 2, 3 3/4 of an inch. So each one needs to be 3 3/4 of an inch in, and that would be 3 3/4 of an inch on center. And I want to set these at the exact same angle as this leaf spring pad. So this leaf spring pad is currently at 0.3 degrees, just like the frame is. So I want to set these at the same 0.3 degrees with my angle finder here. So 3 3/4 of an inch inboard and 3 degrees up, or 0.3 degrees up rather. And 3/4 of an inch. Three 3/4 of an inch. Let's go from there to there, and we're at 44 inches. Okay. Boom, 44 inches exactly. Damn, I got lucky. And then from outside to outside, 3.5. Outside to outside, 3.5. Nice. Awesome. Usually I'll do something like this. I'll take my measurements again after it's all welded and realize that something moved, something shifted, and now it's all messed up and I got to grind it out and redo it. But we're good. I measured 100 times. I measured a bunch of times before I even started this video. Measured a bunch of times, set it in place, tacked it. We're good to go. Now I can take this rear end out, finish weld everything, and then we're good. Awesome. Now I gotta get this thing pulled out. I'll probably take it to my friend's house and let him finish weld it because I'm still very inexperienced with the TIG welder. And something as important as this rear end, I want it done right. I'd rather practice on stuff that, you know, isn't bolted to my car, potentially going 100 miles an hour down the road. So I'll take it to my friend's house. I'll let him finish weld it. Maybe I can get some video of that. Then we'll reinstall it. We'll get some axles in this thing. We'll get it on the ground. And then we can start working on setting that body on the frame. So check it out. We'll see you at my friend's house. We'll get this thing tacked in, or finish welding. See you there. All right, so I pulled the rear end out, threw it in the back of my truck, took it down to my buddy Scott's house so he can finish weld everything, and he actually recommended not to finish weld it. He just put some really heavy duty tacks on it so that I can finish building the car, because he says, you know, things change as you're building it. So he wanted me to fully build it, and then if anything changes, we just got a couple of tacks to cut and then reposition things and then fully weld it kind of before it goes off for like powder coat paint and all that stuff. So you put some real serious tacks on everything so it can support the weight of the car. I can get it running and at least drive it up the driveway type thing. And then he got a little OCD on me. This thing had a real ugly drain plug that somebody added in the back. He cut that off, made a plug, TIG welded it in, smoothed it all out. There's this big dent right in the middle of it where a factory drain plug would go, but this one did not have. So, but it still had the indent from the factory from Ford. He hammered that out, smoothed it out, grinded it smooth, and now it looks great. So thanks a lot, Scott. I know you're watching. Cool. Thanks a lot for watching, guys. We'll see you on the next one where we get an engine in this car, or in this frame rather, so we can build a car or truck. Thanks a lot.